value from a formula. So I have just, okay, good. So I have just substituted all the things. So I expect you to calculate the value and give me the value soon. Okay. Okay. Just calculate the value and give me the value 50. Sushant Nayak. Sushant, are you there?
$19.38 into 10 to the power 3.
Okay, sad. So shall I take it as something 19.38 kilonewtons? That would be fine, I guess, right?
Yes, sir.
I was asking Sushant Naik. Okay. Google Meet present. Sushant Naik. Then Control F. Sushant Naik. Okay. So once the dynamic load is being calculated, just look for anything. Still have to calculate something in this problem, or we can end up this problem. Let me cross verify. So we have calculated the module. We have calculated the phase width. Just now we have calculated the dynamic load and the wear load. So wear load is something new, which are going to calculate it now. So all of you open your data handbooks for that and check the expression for the wear load or something data which is available in the data handbook through which I can calculate my wear load. So wear load would be generally given in the form of F to the suffix W, which is the wear load. This is the fourth thing which we are supposed to calculate, which is known as the wear load. Okay. So just check in the data handbook, all of you. Very good. Nitish, page number. Okay. This is a table. Page number 208. Something. What was it? Page number 208. 12 point. What is this? Okay. 12.5a. So here is the expression for the wear load. You can take it from this. Okay. So FWF. Can you just show me the expression, or I'll just take it from here? I do have a data handbook here. B1B, KF, and K. So all plenty of parameters are there. Okay. So since whether the design is based on GAR or pinion for this particular problem, I forgot. One is based on GAR. Now, do you know the value of D1? What is the value of D1? It is 120 mm, isn't it? Am I? And similarly, the value of B. Give me the value of B.
80.
80. Okay. Now, any information regarding this fellow, Kiv, in the data handbook? Okay. So here he has given, just look here. Q is called as what? Something ratio factor. Okay, either you can go with 2D2 some divided by D plus D1 or 2Z2 divided by Z2 plus Z1. Okay, just go with it. I would take Z. So it is something like this. It is Q from the data handbook. He says Q is equal to 2 times of Z2 divided by Z2 plus Z1. So I have the value of Z2 and Z1, so I would just substitute it 2 cross 96. 2 cross 96 divided by 96 plus 16. So what is the value of Q there? What is the value of Q?
1.714.
1.714. That's great. Next, any information with this particular parameter K, just check. Here he has given. It is nothing but called as load stress factor, he says. So you have to pick this particular expression there. Okay. What is that expression? I'll just write it. It is sigma ES square sine alpha. Sigma ES square sine of alpha divided by 1.4 into 1 by E1 plus 1 by E2. If there is any mistake, just let me know. Even he has mentioned the table number 116 and 17 for this. So I'll go to that particular table number 16 and 17, 12.16 and 17. Let us see what we have there. Okay, table number 16 is this. Okay, and table 7 is this. Very good. That's great. Again, you can go with directly. You can get the value of K from the table itself. For that, you need to have the BHN of the pinion and the gap. Do we have the gap? Do we have the Brinell hardness number of pinion and gap in the given data of the problem? Do we have it?
Yes, sir.
Okay. So what is the value? Just let me know. So BHN. First, we shall talk about pinion. Okay. Now all the circles is for the calculation of value of K. Okay. So BHN. First, we will talk about the pinion. Pinion BHN is equals to how much? It is 250, correct? And it is made up of cast steel. Even I would write that. Cast steel. Great. Next, CI. BHN. How much? Not CI. Because CI is the material. Cast iron is the material. But it's a GAR thing. So, GAR. Now, what is the BHN of GAR? 350? Sorry, 180. Am I right? Am I right? Okay, with this particular things, can I calculate using that particular table? Let us see. Pinion, we have 250. I would mark 250 here. 215, which thing I should mark? Okay, so we need to look for the cast steel. So cast iron steel, let us. In the other table, what we have. Okay. We have to look for cast steel, and I have marked the 250 under the cast steel. Next is gear material is cast iron, so I would go with cast iron here, and the BHN is 180, correct? not given for gear. Okay, you can take it from the data handbook then. I would just check the given data. For this, what it is given, long problem. Okay, only for this one is given and other thing is not given, isn't it? But when you refer a data handbook, see this particular column you have to refer there. Okay, this particular box, because it is cast steel here. Okay. So 250 and the cast iron is the gear material, I guess, right? That is given, right? He has said that gear material is cast iron, yes or no?
Yes, sir.
Okay, then I would take it as 180 from the data handbook. And so E1 and E2 are given in the problem, right? As we have calculated the dynamic load, E1 and E2 are given in the problem, right?
Yes, sir.
So in that case, what you have to do, you have to just pick the value of endurance limit. See here, all of you just zoom it out. Endurance limit is sigma to the suffix es, and the unit with what you have to pick up as mega Newton per meter square. So come back to our selection of materials where we have selected cast steel for pinion and cast iron for gear. So refer in this particular column, refer in this particular row to get the value of the endurance limit. Got it? So what is the value of endurance limit there? Sigma to the suffix es, 617.8. I would take that particular value there. So from data handbook, I would write data handbook, just write the table number. We'll write now. I will forget the value again. It is 617.8. So sigma es, you have taken at 617.8. It is mega Newton per meter square is the unit. Then nothing but megapascal. So just write the table number even. It would be helpful for you. What is the table number? 12.16 page 239. So I have taken this particular data from 12.16 page 239. So I have taken the value of sigma es. So sigma es is being known. What is the value of alpha? What is the value of alpha? What do you mean by alpha? Any idea? If you accidentally discover something new notation like this, now we have discovered alpha, isn't it? Already have taught you, but you have forgotten it. If you accidentally forgot such things, what you have to do is just go with the data handbook, page number 1, always. Okay, there each and every parameter would be given there. Just look for the alpha. Okay, what do you mean by alpha over there? Yes, it's a pressure angle, isn't it? So has he given the pressure angle in the problem? He has set 20-degree involute stop something. No, that is nothing but your alpha value. So you can just write it in the bracket to know it better. So you'll write it as the pressure angle. Clear? Now, E1 and E2, I guess you know it. E1 how much? E2 how much? Just let me write it here. E1 is 96, I guess, right? And E2 is 207. Okay, into 10 to the power of 3 megapascal into 10 to the power of 3 megapascal. Now, all the values have been obtained, whatever is required. Now, substitute the value to calculate the value of K over there. Sigma es, how much? 617.8, its whole square. Where we have taken it from the table, 12.16 cross sine of alpha. Alpha is 20 degrees divided by 1.4 into 1 divided by E1 is 96 cross 10 to the power of 3 plus E2 is 207 cross 10 to the power of 3. Just substitute and give me the value of K. So always remember, whenever there is a formula is always preferred. Okay. Whenever the even and E2 values are given, go with the formula. That will always yield you a good results. Do not go with the table values. Whenever you have a formula, just go with the formula. Okay. Table values are inaccurate always. K 1.42. Very good. Very good. So once I have got the value of K, I have to calculate the value of FW. FW is nothing but D1, B, K, and K. Substitute it. D1, I have 128. Just substitute and give me the value directly. All the values you have, just substitute it and give me the value of K. Abhirami. Abhirami.
Yes, sir.
Okay. So give me the value of FW.
So I'm calculating now. I don't have calc, so I'm doing in phone. So it will take time.
Okay. So better, where is your calculator? Is it in college?
Yes, sir. Since I'm staying in hostel.
Okay, you are staying in hostel right now.
No, no. Now I'm at home, but I get my things at there.
Acha. No issue. So have a parallel arrangement for it because it has a lot of calculations. No, you should not be in a trouble. Always cope up with what it will be dealt here. Okay, always be in the same pace with me.
Okay, sir.
Very good, guys. That's good. That's for module number 7. So since I have calculated for module number 8. Just give me the value for this thing. Okay. I would take the value and discuss now for module number 7. So now you will be in trouble. So m is equals to 7, then your FD value would be something 19.08, isn't it? And okay, FD value. This is right. Now for module number 8, it is 24.9. Okay, 24.9. Now, why are you doing all these stuff? So whatever I speak for next 2 minutes is very, very important step in your total design of care experiment. Okay. Now, there are couple of loads I can say. You have calculated the wear load. You have calculated the dynamic load. Okay. And in turn, in some of the problems, even you will be calculating the endurance load also. Okay. Many number of different loads you will be in calculating. But the funda is the main thing that we need to concentrate is on the dynamic load. Okay. So this particular dynamic load should be less than all the loads you have calculated. Take my words and listen my words once again. This dynamic load should be less than all the loads you have calculated. It might be wear load, it might be endurance load or something other load also. But the dynamic load should be the minimum of all this. Okay. You can even check in a handbook also. What was the page number through which we have picked up the formula for FW?
208.
See here, even here also he has mentioned FW should be greater than FD. That means FD should be smaller, isn't it? Yes or no? He has mentioned here, see? Correct? So what I told you is FD, that is the dynamic load, should be less than all the loads you have calculated. Now, give me the value of dynamic load. Now, I will get the comparison for module number 7 and module number 8. Okay. Now, for module number 7, what is the dynamic load? For module number 8, what is the dynamic load? What is the wear load for module number 8 is 24.9, isn't it? Kilonewtons. Similarly, the wear load for module number 7, I have got it as 19.08 kilonewtons. Now, I have calculated the FD value, isn't it? It is 19.38 for module number 8. And what is the value of FD for module number 7? Can anyone give me the value? Module number 7, FD value is 17.84. Now, I will talk about the module number 8 now. Okay, I will talk about the module number 8. So whether the FW value is greater than or equal to FD value here. Correct? Whether the wear load is less than the dynamic load. I told you always, I would just highlight here, always dynamic load should be what? That is my criteria I have set. Okay, should be smaller. Now, in the case of module number 8, whether the dynamic load is smaller when compared to the wear load, that is my question. Yes or no? Hey, answer, man. Whether the wear load is greater than the dynamic load. I mean to say whether the dynamic load is less than the wear load. Yes, isn't it? Now, then you can say the gear design is safe against the wear. Now, therefore, you can say the gear design is safe against the wear. Okay. Now, come to the module number 7 now. Whether in this case, the wear load is just lesser than the dynamic load, yes or no? In case of module number 7. Whoever calculated the module number 7, I am asking you. So the dynamic load is lesser when compared to wear load. Here also you can write that what? Here also you can write what? The gear design is safe. Therefore, add therefore there. Okay. Therefore, the gear design is safe against the wear. So if you write this particular sentence, if you prove that your dynamic load is less than your wear load, you will get 20 marks straight away. Getting my point? This is how. And what if your wear load is lesser than the dynamic load? What do you have to do according to you? So if we encounter such situations, we would get to know what to do when the wear load is lesser than the dynamic load. Okay, once we encounter such situations, I will give you the solution. Till then, follow this. So always, which has to be a lower value, whether the wear load should be a lower value or whether the dynamic load should be a lower value. Which one has to be a lower value?
Dynamic load.
Dynamic load should be a lower value. So those guys who have selected module number 7 are also in the safe zone, and those guys who have selected module number 8 are also in the safe zone. Okay. Now, understood about this problem? Any doubts? Should I discuss about it still more? Or shall we move on to the next?
Sure.
Aradvi, kedu.
ಸರ್ ಅದು ಸಿ ಉಂಟಲ್ಲ ಸರ್, ಡೈನಮಿಕ್
C
ಲೋಡಿಂಗ್
ಉಂಟು.
ಡೈನಮಿಕ್ ಅದು ಸರ್ ಸ್ವಲ್ಪ ಅರ್ಥ ಆಗಿಲ್ಲ ಸರ್.
C antadilla. So while you are calculating the C, okay, you'll be having two options for you. One thing, you have to go with the formula which is given here. Just go with this thing. Yes, you have a formula here. Either you can go with this particular formula, or you can directly go with the table which is mentioned here.
ಸರ್ ಅದು ಟೇಬಲ್ ಇದೆ ಅರ್ಥ ಮಾಡ್ತೀರಾ ಸರ್ ಅದು?
Sure. ಅದು ಯಾವ ಟೇಬಲ್? 12.12. ಏನಾಯ್ತು ಇದಕ್ಕೆ? ಅರೆ ಸತ್ತು ಬಿದ್ದಿದೆ. ಓಕೆ, 12.12 ಟೇಬಲಿಗೆ ಬರುವ. ಇಲ್ಲುಂಟು. ಸೊ ಈ ಟೇಬಲ್ ಅಲ್ಲಿ ನಿನಗೆ ತಗೊಳ್ಳಿಕ್ಕೆ ಅಟ್ಲೀಸ್ಟ್ ನಿನಗೆ ಏನ್ ಬೇಕು? ಮಟೀರಿಯಲ್ಸ್ ಬೇಕು. ವಾಟ್ ಇಸ್ ಗೇರ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ಅಂಡ್ ವಾಟ್ ಇಸ್ ದ ಪಿನಿಯನ್ ಮೇಡ್ ಅಪ್ ಆಫ್. ಸೊ ಇಫ್ ಯು ಹ್ಯಾವ್ ದ ಮೆಟೀರಿಯಲ್ ಕಾನ್ಫಿಗರೇಷನ್ and the tooth configuration, suppose 20 degree involuta, 20 degree stub bar, or 14.5 degree involuta. When you have the data, either you can go with 14.5 or 20 degree or 20 degree stub based on the data which is given in the problem. So if he has mentioned whatever the material is, you can go with this particular material there. Okay. Now, in order to choose it, you have to know the error, whether it is 0.01, 0.2 or 0.3. So from where will you get the error? Again, you have a table for that. Go to this particular table number. So E is a measured error in action between the gears in mm. So you have to go with table number 12.13, he says. Let us go and check table number 12.13. 12.14. So illi, based on the velocity, so in the gear velocity, adra mele you will pick up an error. Suppose in this particular problem, suppose in the last problem, if the velocity was 6, then you have choose the error to be 0.059. Correct? 0.059 and 0.06 ಗೆ round off ಮಾಡಬಹುದಾ? Can I do it? So ಈಗ I will come back to the another table. Now I will come back to here. Now I will come back to the another table. You have fixed upon the material, cast iron and steel, and you have fixed upon the gear tooth, which is 20 degree stuff, isn't it? Now the only thing you have to fix upon is the error. So you have fixed upon 0.06, then you will come back here and pick this particular value. Okay. This is how you will do it with the table. But none point in andre, when he has given the values of E1 and E2, when he has given the values of E1 and E2, then you are predominantly, you have to go with the formula itself. You cannot go with the table because E1 and E2 kottidalva avanu. That is what I have written here. So always prefer a calculated value when E1 and E2 are given. Red dalli bartidane.
Okay sir.
Clear aitala?
Ha sir.
Any other doubts in this particular problem? Any other doubts? Okay, now the next problem what you are going to solve, this particular problem covers should we substitute E1 and E2 in giganewton and meganewton? Just check there. If you have a doubt, go with the data handbook. No, go with the data handbook. It should be in megapascal itself. Okay. Elastic modulus of the gear and pinion. He has not given anything. So it should be in megapascal. You can write a note in it. Okay. Megapascal. Not meganewton it is. Meganewton per meter square. Fine. Whatever it is. E problem ali enagutte. It is a totally a design oriented problem. This particular problem. And if you solve this, it will cover all the aspects in this per gear design problem. Very, very important problem. So just copy the data. And I want everyone to do it. Okay. Meanwhile, all of you just mark your attendance in the Google Sheet, which I have provided you. I will take it off in next 3 minutes, so just mark it. ಆಯ್ತಾಳೆ ಇನ್ನೊಂದು 20 minutes. ಹೌದು ಅದು ಫ್ಯಾನ್ ಡಿಸ್ಟರ್ಬ್ ಆಗ್ತದೆ ಅವರಿಗೆ. ಕಮ್ಮಿ. Shall we start solving this? Or still do you need time to copy the question? Okay, most of you are having very less attendance. So please do make sure you attend all the classes and mark your attendance. Because again you will be in trouble. Okay.
Sir.
Hello, Girish.
Attendance error, sir.
Sir, nangu sir, Sumit. Sir.
ಏನು ಸಿಂಕ್ ಆಗ್ತಿಲ್ಲ ಅಂತ ಸರ್, ಎರರ್ ಬರ್ತದೆ.
ಹೌದು ಸರ್, ಎರರ್ ಬರ್ತುಂಟು.
ಸರ್ ನಂದು ಯಶವಂತ್.
ಎಂತ ಹೇಳ್ತಾ ಇದ್ರಿ? ಏನೋ ಕಟ್ ಆಯ್ತು.
ಎರರ್ ಬರ್ತಾ ಉಂಟು ಸರ್ ಸುಮಿತ್.
ಅಟೆಂಡೆನ್ಸ್
ಏನಂತ ಎರರ್ ಬರ್ತಾ ಇದೆ?
ಅಟೆಂಡೆನ್ಸ್ ಇದೆ ಅದು.
ಅಲ್ಲ, ಏನಂತ ಎರರ್ ಬರ್ತಾ ಇದೆ?
ಸಿಂಕ್ರೊನೈಸೇಷನ್ ಎರರ್ ಏನೋ ಬರ್ತದೆ.
ಸಿಂಕ್ರೊನೈಸೇಷನ್ ಎರರ್.
ಹೌದಾ? ಸೊ 44-45 ಮೆಂಬರ್ಸ್ ಮಾರ್ಕ್ ಮಾಡಿದ್ದಾರೆ. ತೊಂದರೆ ಇಲ್ಲ, ನಾನು ಮಾರ್ಕ್ ಮಾಡಿ. ಗಿರೀಶ್ ಅಲ್ಲ ಮಾರ್ಕ್
ಸುಮಿತ್
ಮಾಡಿದ್ಯಲ್ಲ?
ಸರ್ ಮತ್ತೆ
ಮಾರ್ಕ್ ಮಾಡಿದ್ಯಲ್ಲ ಗಿರೀಶ್ ನೀನು?
ನನ್ನದ್ರಲ್ಲಿ ಬರ್ತಿಲ್ಲ ಸರ್.
ಅಚ್ಚಾ, ನೀನ್ ಮಾರ್ಕ್ ಮಾಡಿದ್ಯಾ. ಆಮೇಲೆ ಸುಮಿತ್ ಅಲ್ಲ?
ಸುಮಿತ್. ಹಾ,
ಇದೆಂತದ್ದು ಏನೆಲ್ಲ ಬ್ಲ್ಯಾಕ್ ಎಲ್ಲ ಮಾಡಿದಾನಲ್ಲ ಕರ್ಮಕ್ಕೆ. ಸುಮಿತ್ ನಾನು ಮಾರ್ಕ್ ಮಾಡಿದೆ. ಓಕೆ
ಸರ್, with me Fazil sir.
ಫಾಜಿಲ್, ಏನ್ ಸಮಸ್ಯೆ?
Same thing sir. I'm not able to. Yesterday also it was there sir. Then you asked me to update email.
Okay, give me the email address. Let us see.
FazilAli26@gmail.com.
You mean in chat box? Check the chat box. Chat box. ಅದರ ಸ್ಕ್ರೀನ್ ಕಾಣ್ತಾ ಉಂಟಾ?
ಇಲ್ಲ ಸರ್.
Fazil Ali. I've sent you, Fazil. Just check. Okay, you can mark it now.
Okay.
Let us start the problem. Okay. So design a spur gear to transmit 20 kilowatt of power. This is, so I would just write down the given data. So the power is being mentioned as 20 kilowatts. Very good. 20 kilowatts. While operating 8 to 10 hours per day. So the gear is being operated 8 to 10 hours per day. Okay. Next, sustaining medium shocks. So it is sustaining medium amount of shocks. Medium amount of shocks it is being sustaining. Okay, good. From a shaft rotating at 1000 rpm to a parallel shaft which is rotating at 310 rpm, he says. So I would take N1. So N1 to be the 1000 rpm. Okay. Similarly, I would take the value of N2 to be 310 rpm. So yav the pinion, yav the gear. Which one is pinion and which one is gear? Just by looking at the speeds, you have to say. So which one is pinion and which one is gear? Whether one is pinion or two is pinion. One is pinion because the smaller wheel will rotate at a higher speed. So pertaining to that, this is a smaller one and this is a larger one. So this is a gear and this is a pinion. So I would take this as 1 and I would take this as 2. Very good. Z, next what he has mentioned, just let us read. Assume the number of teeth on the pinion to be 31. That means the value of Z1 to be how much? 31 number of teeth are there. And 20-degree full depth involute tooth profile, he says. So I would just write it here, 20-degree full depth involute So it is not stub, it is full depth. Okay. Full depth. Involute profile. So from this, I can even judge alpha to be 20 degrees. Next. The material of the pinion is C40 steel untreated. Okay. Pinion material. So I would just write C40 untreated steel. Okay. C40 untreated steel. The material of the pinion. So even he has given the value of sigma D1 over there. How much it is? 206.81 Newton per mm square. 206.81 Newton per mm square is nothing but, again, it is megapascal. Very good. Next. And the gear is of cast steel. So I would just write it here. It is of cast steel gear. Cast steel. So it is cast steel gear. Okay. Cast steel. 0.2% carbon. So 0.2% carbon. Again, it is untreated. So I will just move this a bit. It is untreated. Cast steel. Cast steel. Very good. Which has the design stress value. Again, he has given as 137.34 Newton per mm square. Very good. Next, what he has given, check the design for dynamic load. What we need to find here. Okay. To find what are the tasks given. The first task is being given as check the design for what? Dynamic load. Excellent. He has given the load factor directly. I would just take it as C is equal to 522.464 Newton per mm. He has given the load factor directly, and also for the wear load. Next, what you have to do, even you have to check it for the wear load. Wear load, taking the load stress factor. So K is directly given in the problem. K is directly given. So it is 0.279 Newton per mm square. The value of K is given. And suggest suitable hardness, he says. That means you need to give the value of BH and values. Suggest. We need to suggest what? We need to suggest suitable hardness. We need to suggest the suitable hardness. Any doubt in the data given? Any doubt in the data given? Shall we go on with the solution? Okay. Now, so it's a long problem. So what is the first step, guys? What is our first step? Calculate the value of I, which is given as N1 by N2, in turn equal to Z2 by Z1. That is in turn equal to D2 by D1. Any one of this you can take. So N1 by N2, you know the value. So calculate the value of N1 by N2. How much is that? That is 1000 divided by 310. So what is I? So I is equal to 3 point something. How much? 3.22. Okay. So 3 point, whether it is recurring 22222 something like that. If it is recurring, you have to take the next value. Suppose 3.225. We take that particular value itself. So 225. So this is the value of I. So once I is calculated, what you have to calculate? Z1 is given. So Z2 you can calculate. Z2 is equal to I times of Z1. That is equal to 3.225 cross 31. So what is the value of Z2? $99.975. Give the whole number. Shall I take it as 100? Okay. So Z2 value is 100. What is the next step? What is the next step in the problem? What do you have to do? Strength factor. So identify the weaker part there. So identifying the weaker part. So how we are going to identify it? Based on the strength factor. So that is equal to sigma d cross y. Okay. So for 20-degree full depth involute, what is the expression for y in the data handbook? So it is 0.154 minus 0.192. So it is 0.154 minus 0.1912 divided by Z. So do you have the value of Z1 and Z2? So just calculate Y1 and Y2. 0.154 minus 0.192 divided by Z1 value is 31. Similarly, 0.154 minus 0.192 divided by Z2 value is 100. So what is the value you are going to get? Similarly, calculate the value of sigma D1 and Y1, sigma D2 and Y2. Give me the values, guys. So I will take it from the textbook itself here. So it is 0.12. Just check values. 0.12.46, 0.1449. Okay. Sigma D1 is 206.81 cross 0.1246. So the value is 25.7 megapascal. Similarly, 137.34 cross 0.1449. So here the value is 19.90 megapascal. So yes, on which should I design my gear? Should I consider the pinion or should I consider the gear? Yes, so it is a gear. Sigma D2 cross Y2 is less Therefore, design is based on the gear. Okay, so all the design calculations will be using the gear for that. So while coming in the next class, okay, before you come to the next class, I want you to fix upon the module. Okay, I want you to calculate the value of, so I would just write it here. Okay, by the next class, what you have to do, you have to find the module. Okay, once your module is being found, next you have to calculate the value of FT, sorry, the value of FD, okay, and calculate the value of FW. Just calculate, we will let you know what to be done and how to check whether it is safe or not. So you have to find the value of module, you have to calculate the value of FD, you have to calculate the value of FW by the next class. Is that clear? So I would be
Thank you, sir.
checking the values from every one of you, okay? Everyone has to do it. Module, dynamic load, and the wear load has to be calculated by you. All the parameters are given. There is nothing confusion in this problem. If at all, if you get any doubts, you can call me up, okay? So we will meet up in the next class and continue this particular problem, which is based on gear again. Till then, have a nice time ahead. Take care. Bye. Okay.
Thank you, sir.